Whether you're using 360 wide drop side dress on a toolbar or you're running a self-propelled version of 360 wide drop, here are a handful of tidbits for getting the most out of that ever so critical nutrient pass. When it comes to implementing a new system, it's important to get off on the right foot with a good installation. Print instructions are included when a new system ships from 360 Yield Center, but you can also find both print and video instruction links by going to 360yieldcenter.com, clicking on Y-Drop, click on Support, and then scroll to find those links. First, let's talk about orifices. Whether you're using an orifice or a variable rate nozzle, it's important to remember there's always one located on each side of the output side of the Y rather than one on the input side. On the outside drops on the boom, you're going to select an orifice or a nozzle which delivers roughly a 1.5x rate, as that row of plants on the outside there is only going to be fed on one side. You can always consult our orifice and nozzle selection guide when it comes to sizing. Positioning a check valve above the Y, that's the input side, on that Y-drop base is going to help minimize liquid drainage when that system is turned off. In other words, you're going to minimize splatter when you're turning on the headlands. You can protect equipment from the drainage throughout the application process, and as well avoid liquid drip during transport. Regarding drag hoses, you're going to position those to deliver a stream of liquid right alongside that base of that plant. So carrying the Y-drop base roughly a foot off the ground and utilizing our most common drag hose, which is a 30-inch drag hose, means you will have about 3 to 4 inches of hose contacting the soil. If you are running higher than that and having less contact with the soil, you kind of engage in a little bit of a skipping activity. And if you're trying to run lower and having more drag hose in contact with the soil, you get a little bit of a snaking activity with it. So running about 12 inches off the ground is an ideal place to be. But if you're operating in a hilly terrain and it's a lot more difficult to maintain a relatively consistent height, we also offer a longer 36-inch drag hose, which gives you the opportunity to run that base a little bit higher off the ground, and sometimes that can be helpful. To accomplish placement, adjustments can be made to the wing setting on the base unit. There are really 4 positions which essentially correlate to 15-inch rows, that 20-inch row, your 30-inch row, and then wide 36, 38-inch row widths. In addition, you can loosen the hose clamp where that drag hose is connected, twist the drag hose, and then retighten it in place. What you're attempting to do is orient that hose so it's relatively straight alongside that row. If you happen to be running that application in smaller corn, say shin to knee-high corn, it can be beneficial to position these at even narrower settings, allowing that hose to drag instead an inch or 2 away from the base of the plants. Infield travel speeds are somewhat dictated by crop size and field conditions, but it's really common for applicators to run 10 to 12 mile an hour. Some users may operate at higher speeds, but considering the value potential of good placement and the high input cost of nutrients, operating around 10 mile an hour certainly helps improve consistency of where that stream of liquid is positioned. An operating pressure of 30 to 60 psi is more than adequate. Lower pressures risk intermittent flow, but higher pressures are really not needed. The key is simply accomplish a stream of liquid, not a spray pattern. Common nitrogen application rates probably range somewhere in the area of 10 to 40 gallons. That's going to equate to 40 to 120 units of nitrogen, depending on the formulation of the product that you're using. Now, application rates are a reflection of agronomic need and the sprayer capabilities, but picking the right orifice or nozzle along with traveling the appropriate speed is really what matters. Is a stabilizer suggested? For early season Y-drop applications where that crop canopy is still more open and possibly the prospects for rain soon after that application are not overly promising, sure, consider using an inhibitor product. It can help manage volatilization of that UAN and ammonia loss. How about add-in products? Well, to help the plant's in-season nutrition needs, including sulfur in the application is certainly worth considering. Local agronomic consultation can be helpful here, but a 10-to-1 nitrogen to sulfur ratio is a reasonable rule of thumb. There may be other nutrients, mobile nutrients, or additives to consider including. Really, the placement feature of 360 Wide Drop and its ability to be utilized from early to late stages of crop development allow for a lot of different possibilities. There's little doubt 360 Wide Drop outperforms other products that are offered in this marketplace. And hopefully this overview of insights is helpful in making your experience with 360 Wide Drop even better. You can reference 360yieldcenter.com for resources on best practices as well as frequently asked questions.